Welcome to Santi Peace for Mathematics. In this video, we'll talk some general theorem on series and we accept these theorems without proof. So the first things that we need to note that the nature of the series remain unchanged if a sign of all the terms are changed. So that is the first things that we should note, that nature of a series remains unaltered if the sign of all the terms are changed. That means if you have given a series summation of un, if it is a conversion series, then if you change by minus un, then also it is a conversion. If this series summation of un is a divergent series, then this will be a divergent series. The next one, second one, is the same. The nature of series remain unaltered if you add or omit finite number of terms from the series. So a finite number of terms are added or omitted. That means if you have a series summation of n running from 1 to infinity un, if this series is convergent, then this series, that is n running from 1, instead of 1 I will start with m to infinitive un, this is also convergent, where the value of m, if I can say, it is bigger than 1. If it is smaller than 1, that means I have added certain terms here, then also it will be convergent. If this is convergent, then this will be convergent. If this is divergent, then this series is divergent. So that means, but it has to be a finite number of terms. So whatever the finite number of terms you will add into this series, then the nature of the series will not be changed. It will remain same. So if the series is convergent, the another series, that is if you add this term or subtracted some terms from that, omitted that some terms from the series, it will be remain same. The third things is also with this nature of the series remain unchanged if each term of the series is multiplied or divided by the same number, same fixed quantity which is different from 0. If you have a series un running from 1 to infinity, and this series summation of n running from 1 to infinity un is convergent series, then if you multiply each of this term by c, that is c into un, n running from 1 to infinity, if this c is non-zero, then this series is convergent. If it is convergent, if this summation of un is convergent, this will be convergent. If summation of un is divergent, then this series is divergent. Or you just multiply by 1 upon c, then also we'll have a same result. That means summation of un is convergent, then this 1 upon c into un, summation of 1 upon c into un is also convergent. So the nature of the series will not be changed if you multiply by fixed quantity or you divide that fixed quantity, but that fixed quantity should be different from 0. Now the next definition is the positive term series. So the positive term series, an infinite series which all the terms after some particular terms are positive, it is called positive term series. So an infinite series in which all the terms after some particular term are positive, it's called positive term series or just a positive series. Sometimes it's also just known as a positive series. For example, I can give you that series is of the form minus 7 minus 5 minus 1 plus 5 plus 13 plus 23 up to so on. So this is a positive series. Why? Because after third term everything is a positive. So that's why this is an example of a positive term series. And there is very interesting result of positive term series that we need to understand here, that if summation of un of a positive term series is either convergent or divergent. it cannot be oscillatory series, but it cannot oscillate. So it has to be two things is possible for positive term series. Either the positive term series is convergent series or it is a divergent series. For example, we have talked about the summation of un. If it is convergent, then limit of un is 0 as n tends to infinity. That is the result we have discussed about the necessary condition of convergent series. But if I put one more extra condition here, it is a positive term series. That un is a positive term series which is convergent, then summation of un is 0. And we know that the converse of this result is not true. But a negation of this statement is true. That means a limit of un is non-zero as n tends to infinity. Then summation of un, we know it is non-convergent. But you know, if this summation of un is positive term series, then definitely you can say that a series is divergent. That means you know that series is positive term series. Then according to the zero test, you can just say that a summation of un is divergent instead of non-convergent, because a positive term series will never be oscillating. Then we'll have this theorem, which is about the summation rule, difference rule, and the constant multiplying rule. That if the two series, that is summation of an is equal to a, when I say it is equal to a, it does not mean that it is equal to a, it is converged to a. And summation of bn is equal to b are convergent series, then you will have the first result, that is called the sum rule, that is summation of an plus bn, that you can write down as summation of an plus summation of bn, and which is a plus b. The second one is the difference rule, that is summation of an minus summation of bn, that I can write down summation of an minus summation of bn, which will be a minus b. And the third rule, that is summation of k into an, will write down as k into summation of an, which is we can write down as k into a, where k is any number. So these are the three rules which we have to understand. The corollary of this results, we can say that every non-zero constant multiply or divergent series is divergent. So another result that we need to understand, that the every non-zero constant multiply with divergent series is divergent. That we already discussed, that if you multiply a constant, non-zero constant, to any series, the nature of the series will not be changed. So it is exactly the same things we have. The second thing that we need to have understand here, it's very important. If summation of an is convergent and summation of bn is divergent, then what we can say about summation of an plus bn and summation of an minus bn? So these two series, one of them is convergent, another one is divergent, then both this series will be divergent. We cannot say that it is a convergent series. So we can say it is a convergent if both of them are convergent. If any one of them is convergent, other one is not, then we cannot say anything. We will give you one example here. Let us consider the sequence summation of an is summation of 1, that is 1 plus 1 plus 1 infinite times. That means this series is divergent. Another series I am taking is minus 1. This series is minus 1 up to so on. So all the terms are minus 1. This series is also divergent because it is minus infinity. Here you will have plus infinity because it is adding 1 infinitely many times. But what will be the sum of these two series, that is an plus bn? As per this, it is a sum 1 plus minus 1. So that will be 0 plus 0 plus 0 up to so on. So it is a 0 series which is convergent. So ultimately, by this example, what I want to say is that a summation of an and summation of Bn is divergent, then it may happen that, may or may not, we don't know, but it may happen that summation of An plus Bn is convergent. It may true that if summation of An plus Bn is convergent, then we know that summation of An and Bn is convergent. We cannot say that. So if it is divergent, both of them are divergent, then this summation of An plus Bn is convergent. So that result is not true. Now here we'll discuss certain examples based on these rules which we have discussed just now. Let us see this example. Discuss the convergence of this series, that is 3 power n minus 1 by minus 1 upon 6 power n minus 1. Now just observe that this series I can write down or rewrite as summation 1 running from 1 to infinity 3 raised to n minus 1 upon 6 raised to n minus 1 minus 1 upon 6 raised to n minus 1. So that is, we can write down summation n running from 1 to infinity 1 upon 2 raised to n minus 1 minus summation n running from 1 to infinity 1 upon 6 raised to n minus 1. And one should note that the series summation 1 upon 2 raised to n minus 1 n running from 1 to infinity is a geometric series with ratio or with a which is 1 and r will be 1 by 2 and which is less than 1. So which converges to upon 1 minus r. What is a is 1, r is 1 by 2, so it is 1 minus 1 by 2 and hence this will gives me 2. And the series, that summation of 1 upon 6 raised to n minus 1 and the series summation of 1 upon 6 raised to n minus 1 n running from 1 to infinity is a geometric series with a is equal to 1, r is 1 by 6 which is less than 1. So which converges to upon 1 minus r, which is a is 1, r is 1 by 6, so it is 1 minus 1 by 6. So if you can simplify this, this will be 6 by 5. So hence the given series, that is summation of 3 raised to n minus 1 minus 1 upon 6 raised to n minus 1 n running from 1 to infinity. As we already discussed that is summation of this minus summation of this, and sum of this one will have obtained 2. So that's why it is equal to 2 minus 6 by 5. So that will gives me by the previous result that if the two series are convergent, that means this series is summation of an and this series is summation of bn, both of them are convergent. So that's why this series is convergent and it's converged to this 2 minus 6 by 5, which we can simplify as 4 by 5. Let us have one more example. Second example, summation minus 1 raised to n upon 5 raised to n plus 1 by 2 raised to n running from 0 to infinity. One should note that this series I can rewrite in the form of summation minus 1 by 5 raised to n plus summation 1 by 2 raised to n running from 0 to infinity in the both the series we have. And both the series are geometric series that we can see. So we can write both by 1 minus 1 raised to n upon 5 raised to n running from 0 to infinity is a geometric series with ratio r is equal to minus 1 by 5. And the value of minus 1 by 5 is between minus 1 and 1. And a is 1. So therefore it's converges to a upon 1 minus r. But value of a is 1, r is minus 1 by 5, so it is plus 1 by 5. And if you simplify that, it will gives me 5 by 6. And the series summation 1 by 2 raised to n running from 0 to infinity is also geometric series with a that is 1 and r is 1 by 2. So it is less than 1 and so it is converged to a upon 1 minus r. So a is 1, r is 1 by 2, so that's why it is 2 upon 1. It will be 2. So therefore the given series, that is summation n running from 0 to infinity minus 1 by n minus 1 raised to n upon 5 raised to n plus 1 by 2 raised to n is equal to, as we have discussed that this series is convergent, this series is convergent, so sum of two series is convergent. So that's why it is 5 by 6 plus 2 and it is converged to this number, which will gives me 17 by 6. That's it for this video. If you like this video, please press the like button. If you have any comments, suggestion or a question, please drop down in the comment box below. See you in next video. Till then, bye bye, sayonara.